Hey guys, welcome to the stream. It is Monday afternoon, I believe, and we've made some traps and it's coming along. So last night we made a flaming trap. Now I'm going to show you this one first. So basically, this switches on and off like so. If we run through it, we're damaged. If we run through it while it's not there, we don't get damaged. Okay? So we have our flamer, and it is now a blueprint on its own. Okay, now our next one is a bit more interesting, shall we say. We have this metal ball with a spike on the end. Right, this is basically the start of this, and isn't going to be the final version of it, but as you can see, this metal ball is going to be quite dangerous to a player. So the way it works at the moment is it works out where it can move in the room, and then every X number of seconds it moves either on the X or the Y to a position, new position in the room. Okay, as you can see. Now my idea for this is that if the ball is moving, then you can move. If the ball isn't moving, it can spot you and then basically shoot forward at you and kill you. Okay, so I'm not 100% happy with the movement yet, but it's getting there. Okay, the movement works. So what it does is basically shoots out a line trace on the X plus and minus and on the Y plus and minus, and then basically writes these to two vector 2s to give me a minimum and maximum for the room on the X and a minimum maximum on the Y, and that is where I pick its random positions. Okay, now we are going to have to add sound effects to this, but the other thing is I want our sphere to like have an indicator on it, and that indicator is basically I can't remember why I did the box, collision box. I suppose we're going to need it at some point, but anyway, right, so this is going to be what we could do. Hi, Mr. Spock. How are you doing? Right, so we could basically make this point 1. Right, now it's just a matter here of getting some sort of material onto this. Okay. Oh yeah, I should really explain this to you guys, right? Right, hang on a second. What I'll do is I'll put a directional light in here so that you guys can see the actual ball shooting around the place. Or whatever. Right. Right, there's the ball in the middle. Right. And it's going to move, remember, hi Jess, and it's only ever going to move in the X or the Y. Right. And basically it isn't doing anything here. So this isn't going to hit me, right? Because it can only move on X or Y. So it can't move diagonally. Okay. Now, do you guys want to see how I did this? Basically what I do, right, is I set up the room coordinates, as I said, so this will work in any room, okay? I set up the mins and the max possible positions, and then when I'm going to move the ball, I basically randomly pick whether it's going to move in X or Y, and then whether it's going to move in a positive direction or negative. Check the landscape is at 0. Right, so basically what we do is we calculate a new position depending on whether we're going to move in the X or we're going to move in the Y, whether it's going to be positive or negative. Then we come in here, calculate the new position, and then if it's the X position, we pick a new X, we pick a new X negative. Then if it's the Y, we do the same thing. This sets up the new position here, and we basically lerp it with our timeline, and then we basically set this move speed, which sets the play rate. Okay, and Jess, this is for you. This is what actually changes the speed, right? So basically I get the distance between the 2 points, then divide 1 by that number, then multiply it by a variable called move speed. And move speed determines how fast I actually want the thing to move. Right, and then you set the play rate. Okay? So you'll notice that it doesn't matter how far the ball goes, it takes the same amount of time to go that distance. Okay? It moves at the same speed. Right, so it's up over there, and there it's moved. And you'll notice it isn't moving faster because it's got further to go, it's just moving at the same speed. Right? And notice that it's staying inside the room also. Okay? Notice it never moves outside the room. Okay? Pretty cool, I'd say. It's a bit high though. Not to worry, I can move it down. Okay, so we want something to work here. Now, I've set these up, so we're going to do a material. Right, and it's going to be matte. Underscore, I'm going to call it orb. And we're going to make an instance of this because what we're going to do is we're going to set up a vector parameter, and it's going to be called color. There's a shortcut for that, Jess, by the way. There's a shortcut for dropping everything to the ground. Alt and end. Right. So we're going to default this to, let's say, red. Okay, and we're going to select it from here. Okay, now this is where we want to use the pulse from Well, okay, we'll just get it working first, is the best idea, right? So we'll basically say that, and we're going to do an emissive, but it's going to be like, we're going to do this as a pulsing. This is going to be scalar parameter. Do that as emissive. And in the first instance, we're going to do that as a 0.5. Right? Right. And that's actually right, we'll do that for now, right? We'll work on this. Right, now we can do this a couple of ways, but I'm going to create a material instance. Right? And then on our metal ball, on our cylinder, we're going to have that. Right? Then as you can see, that's red. Now okay, so that's cool, but not cool enough. Right, we're going to set a material here. We're going to call this warning material, and this is going to be a dynamic material. Dynamic instance. Okay. And then in here we're going to create dynamic material instance. And it's going to be our orb. And then on our cylinder orb, we're going to set the material, and that's going to go in there. Then we're going to join these up. Okay. And then we're going to select them all. And we're going to stick this at this. Well, I was going to stick them at the start, but apparently we didn't select all of that stuff there. Right. So we'll do that. We'll do that. Tidy that up. Drag it to there. Right. And now, quite simply, get one material, then set vector parameter. That's going to be color. And value is going to be green. And for some reason it just does not like doing that for me. Right. We do that. Then on completion of our move, we set it back to red. Okay. So we can go 1, 0, 0. Okay. Join them up. Now, when we move the ball, it should be showing red, and then when it moves it should move to green, which it did. Did it too fast. There you go. Better not get hit in the head. You can see it's turning to green now. Okay, so that is our first piece of the puzzle. So we're changing the material instance depending on whether it's about to move or not, or sorry, not about to move, but is moving. Right. Now what I'm considering doing here is changing this logic from not bothering whether it's positive or not. I'm just going to take a value. Right? So basically what that means is I get a value between here and here. Right? And that's actually pretty easy to do. If I, just to kind of bypass this and not totally wreck it, right? If I just get a value between here and here, and then plug that into the X, I can actually do the same down here. Right. As I said, this allows me to just test it out to see if it gives me better results. That goes into Y. Right, and then basically I don't need that other branch. So we could actually take these branches out, but I'm just going to do it like this for now. Right. Right. Well, let's try that. It might be an Unreal Engine 5 thing, but we can test it. All I need to do is bring a ball in. Then if I hit all end, yeah, it pretty does nothing. I know there is a shortcut for it. Let me have a look. Right, we'll try that again, right? So we're on ball. Absolutely. That doesn't work. It says end. Snap to floor is end. Snap bounce to floor is shift end. But yeah, it doesn't seem to do anything. But that was for Unreal Engine 5, I believe. It says 4 and 5. Relax Hub, it depends. It depends if you're going to use blueprints. Oh, okay, let me answer relax first. are you going to use blueprints or are you going to code? In which case, you're going to have to change languages to C++. As far as objects and stuff goes, no, you've probably got a leg up on that one. If you understand Unity, you'll understand a lot of the concepts of what Unreal Engine is doing. It really just depends. So you'd have to answer that question first, Relax Hub, of whether you're going to use blueprints. But what you got to understand is blueprints are just basically code in a visual style, right? You've still got all the stuff that you do in, you know, normal code, like branch is basically if then. Loops or loops, for loop, for each loop. You know, you do all the same things, it's just a visual way of doing it. I've got no idea what you're talking about, Mr. Spock, I'm afraid. Right. So the question has to be, how am I going to do this, guys? What do you think? You've not described the problem. Right? But you sent a link. How did you send a link? I don't understand. I don't see no link. Right, so my options here, right, is what I want to happen is for our metal ball, right, if you move while it is stopped, while the metal ball is stopped, if you move, then the ball can detect you and fly straight at you. So the idea here is to get the player to only move when the ball is moving, okay? Now, what I'm going to have to do is set up collision on our box. We're going to have to set up this collision box, right? Which is going to be the player detection. So, first of all, we're going to have to add a variable. And we're going to have to say player detected. Or wait a minute. No, we're not going to call it that, right? We're going to say player in range. Because we're going to use player detected for something else, right? So we're going to have player in range. To be quite honest, I've never had that issue at all. Right, Jess. Right. Okay. I'm going to save all this for now. You're sidetracking me here. I'm going to have to open another project because this project doesn't use a landscape. But I've never had a problem of, what do you call it, foliage not going on the ground. Always went on the ground for me. Right, where's my maps? Mr. Spock, I'm getting the stinky smell of an add-on or an asset. Right, I obviously can't watch the video, right? So can you explain, Mr. Spock, what the problem is? Okay, so I'm guessing we have if we go into foliage mode, right? So we can basically switch these on. Right, now check your placement here, your min max and stuff like that, align to normal, align to this type of stuff. Right, because look, right, no problems on the ground. Right, let me add some more. Right, so this is all the different rocks, right? I'll take these away. There you go. Now, I don't know where, if you have that, right, but you've got these placement offsets here, right? So I can set these to be Z offset. I can set the scales, whether it's uniform scaling, blah de blah, all of that stuff. But then you're going to have to check your actual meshes to make sure that your meshes are pivoted at 0, 0. Or where they are. right? Because if you're using rocks where the pivot point is not in a very good position, then it is going to bugger it up. Because it's going to use that rock's pivot position when it actually does the placement and works it out. Right? Now, with regard to that, now can I... Right, I still don't know what it's supposed to do. Right, Mr. Spock, you need to tell me what it actually does. Right, so Jess, what I would do if I was you, right, I would check your actual assets and check the pivot points of those assets. Right, because there's obviously something wrong with the setup, because I've done absolutely nothing here. All I've done is went to foliage mode, and there you go, I get foliage on the ground, not a problem, right? And to be quite honest, I've never had any problems with that at all. Oopsie doopsie. I think it's shift, isn't it? Yeah. Right, so, yeah. It seems to me either A, Jess, there's something wrong with the alignment of your ground or whatever, right? That something isn't set to the Z properly, and that's why things are hanging in the air. And basically foliage is kind of supposed to be on the ground, right? So you can't really move it, right? You can't move the foliage, you would have to move the ground. But again, that doesn't make any sense to do that, right? Here's what I mean, right? If I set the offset of the Z to be 10, right? Then is that 10 units? Who knows? I'd probably need to set it to higher than that. So what I'll do is I'll undo that. If I set the minimum to be 10, the maximum to be 500, right? You see, it kind of still doesn't do it. It kind of always anchors everything to the ground. Right, because foliage doesn't hang in midair. Right? That actually doesn't make any sense. Right? Because trees are in the ground, rocks are on the ground, they can't just hang in midair, so there's something wrong with your landscape, and it's either the material that you're using for it isn't aligned properly, right? Or the meshes that you're using for the foliage, their pivot points aren't in the right place, right? So basically, now I don't know why that would happen, because if you set the pivot point too high, then it would actually appear that if it was rocks or flowers, that it would be too far into the ground, right? Similarly, if they were pivoted in the middle, so basically it only makes sense that these, now I don't know how, can we show in content browser, right? So if we look at this grass bush, right, we can show the pivot point and we can see that it's at the bottom, right? Right there. So basically anything, all your models should have the pivot on the ground, right? Now that still doesn't make sense of why your stuff's in the air, right? Because basically if your pivot was too high, then basically you wouldn't see it at all, because it would actually have it under the ground, right? The only way what you're describing happening is if the pivot point is way below the actual model or the mesh, right? Or your actual landscape material is somehow drawing itself below where the actual mesh for the landscape is, right? It's quite hard to explain. Yeah, we'll see what I'm up to. Right, so anyway, we can do two things here, right? Now, our box collision, we cannot connect it to our sphere, right? It's going to have to say to stay as part of the room and not move, right? So what I mean by that is that this here the sphere, or our metal ball of death, is going to be able to move around, okay? But its detection will actually be a static box collision around the room, okay? So we can deduce from that that the relationship between our box collision and our metal ball of death is going to be the min-max values for our x and our y, right? So the kind of interesting thing here is to see how this actually relates to each other, right? So what I'm going to have to do here is say add box component, box collision, right? And we're going to have to calculate the box extents, okay, relating to the starting position against the min-max x and min-max y. Right, so I don't know if that's going to be a ratio or it's actually going to be the values that are going to go in here or whatever. Doesn't actually matter, but we can manually set the z to be that, right? In fact, we could be doing with it being a bit less than that. Right, now we do know that we want our, what we want to do first, right, is check where this is in relation to our head, right? So because basically we want it flying at our head. Okay, I'm actually going to maybe go 150 here and we'll test it. Right. Right. So I think our our number here is 145. I'm going to save that. Right. So what we're going to do is we're going to do some calculations in a second, after I have a cigarette. So if you guys are enjoying the content, hit like and subscribe. I shall be back in 2 minutes. Check out the description for links to Patreon, my previous game, and also my Discord. Be right back. Don't go anywhere. I've got to say, I find it pretty cringy when people say things like smash the like button. It's the same result if you just press it. In fact, it's a better result because then you're not going to break your keyboard. Right. So, this is an interesting mathematical problem, right? Because, number one, we know... Right, okay, this is how I solve problems, okay? And this is a mathematical problem. Now, we've already got the answer, right? We just need to work it out. Or, let me put it a different way. We've already got the answers, or we've already got the numbers that's going to give us the answer, right? Which is basically our min-max x and our min-max y. Okay? So, that's going to give us the size of the room. It's going to give us the center point of the room, because all we need to do is take the value between the two x values and between the two y values, and that's going to basically show us what the center of the room is, right? So, in effect, we can actually do that and then just basically spawn something there for a laugh, right, as a test, right? So what I'm going to do is I'm going to create a custom event. As I said, guys, I've said to you, a lot of you guys in the Discord, you make the coffee, right? You go through each step of how to solve a problem. Okay, so our first problem here is we need to find the center of the room, alright? And we're going to call it here. Now, this isn't going to be the end of how we do it, but it's going to give us our first idea of how to solve this problem, because I don't know the relationship between the extent of our collision box, right? So we've got our box and we've got the extents, but we don't know how these are related yet to the actual lengths or distances in the game, right? Normally you'll just set this up and it'll be colliding with the ball, right? But that's not what we're doing here, right? What we've got to get is the size of this room going from here all the way around and all the way around here, right? We're going to ignore on purpose any entrances or exits, because basically the ball will not move out of the confines of this room, right? Which we've already set up by doing a line trace to each of the different axes, X and Y, right? So, what we'll do in our new function or new custom event is we're going to get X, min and max, right? And then we're going to split the pin, and then we're going to say this minus our minimum, and then we're going to do the same thing on the Y, Oops, daisies. And I'm going to have to do a bit of jiggery pokery with this till I figure out which numbers I actually need. Right, but at the moment that's going to give us the difference between X and Y. Okay? Now we can look at this and actually find out what those values are. And I'll show you me doing that. Right? If I click on the metal ball, I've got X 4091790, and I've got minus 740 to 640. Right? Now, these are going to have a relationship to how far I actually need to move to find the center of the room. Okay. So basically, I divide that by 2. And then I add it to the minimum. Now here's the thing, guys, if I can figure this out, you can too, right? I've not got any special mathematical education or anything like that. I just basically went to school, went to the academy, got a couple of levels, and that was it, right? So as I said, if I can figure this out, then you guys can too. Right, now what I'm going to do here is I'm going to spawn, I usually spawn something really stupid. Spawn actor from class. I guess a candle will do. A chandelier. What about a chandelier? We'll have a chandelier. Sounds like the place. Right, we'll split that. Then we shall split that. Then that's going to be X. Oops, a daisy. Now I'm going to get this completely wrong to start with, by the way. I'm going to say 145, but we'll change this later to the where we actually spawn the metal ball. But this should give us an idea if we're on the right track. And look at that, we have a chandelier. Does that look in the middle to you guys? Kind of looks in the middle to me. Right, so we actually think that's pretty good. Right? I'm going to call that a win so far. Apart from the Z, of course, but we'll type 300. Yeah, it looks centre at me as well. I was surprised that worked. Normally when I do these, as I said, I'm not a mathematician or anything like that, so I normally get it wrong, but I gradually just change it until I get it right. So we know now that our number is kind of right. Okay, but what we want to see is this box right, we don't want it hidden in the game, right? Right, so when our ball moves, right, our box is moving, and that's because we're moving the D. Right, okay. Okay, we could do this a couple of ways. Right, we could actually create a new blueprint which would just store the collision. Right, and then we could fire an interface to tell it if it's colliding with our thing or not. Right, I'll tell you what, that's what we'll do. Right, as a test. Right, and we'll call it BP orb collision, right? And it's basically just going to have a collision box. Okay. Now, we're not going to do anything with it just yet, except we are. Right? So, we're going to need this. Then we're going to do we're going to say BP underscore, we'll just call it collision. Right? And it's going to be BP underscore orb. Right? And then in here we're going to spawn it, and it never seems to like that. Okay. And we'll spawn it at 145. Right. And then we're going to set this here. Okay. And this is going to be good. Well, actually it might not be, but anyway. So what we're going to do here is we're going to delete everything. Then we're going to do custom event. And we're going to basically say set size. And we're going to say XY. And it's going to be vector 2. Okie dokie. And then in our metal ball, we're going to say set size. And we're going to make vector 2D, and these are the positions, but these are the numbers we want here, X and Y. Okay, now we're not going to do anything yet. But what we are going to do is we're going to make this box visible for now. Okay. We're going to press play. And now we have our box in the center of the room. And our thing should run around, basically. Right, and that just stays where it is. So that's the effect we want, because the ball moving around does not affect its where it's going to detect. Okay. Now, what we want to do with our orb is make sure we can now switch hidden in game, and we don't overlap all, we overlap only pawn. Okay, and it's going to be the same for our orb collision. Remember, the collision for the orb now is going to dictate the damage if it hits. Okay, this has nothing to do with what we're working on anymore. We are literally just working on a detection area for our room. Right, now this is going to be any room. We'll be able to do any size of room and then plonk a metal ball in it if we want. It'll work out the size of the room, where it can move, and the detection area. Okay, That's the effect we're looking for here. So when we set the size, right, we're going to break this, then we're going to drag in our box, right, and what we're actually going to do is set the box extents. Okay, we're going to break this, and then we're going to plug in X. Now if this all works, this would be absolutely fantastic. I don't think it will, but we'll get an idea of how it's looking, right? Now if we remember rightly, this I believe was around the 50 odd mark. Okay, but at least we should be able to see what this looks like. If I can manage to drag this properly. Right, so let's have a look, shall we? Look at that, it's perfect. It's absolutely spot on perfect. Right, sometimes I actually amaze myself that some things work exactly how I actually planned it to work. Right, but you can see there, the limits of my room are the actual limits of my collision. Right, now the one thing we're going to do here is we're going to do one more thing, and we're going to set up a variable here called call it parent orb. Okay, and that is going to be metal ball. Okie dokie. And we'll make it instance editable, expose on spawn, save that. Then when we actually create the ball in here, we can just say self and put it straight in there. Okay, and our next thing that we can do, now that we're actually super happy with that because it works absolutely perfectly, which is a bit of a surprise even to me, is we move this into a tidy position, which is about here, and then what we do is we're doing our custom event. Okay, and it's going to have an input, and we're going to say player detect bool, and in the first instinct we're going to say player in range. We're going to set it to here, and that's going to get set to there. Then if we do that, we save that, okay, and then if we go to our orb collision, and then we go to the box, and we begin overlap, then we do the box again, end overlap, right? Then other actor, and we're doing has tag, and we say player, then we branch off of this, right, and then we get parent orb, and player set player in range, and we say true. Okay, then we basically do that, do the same thing, and we set it to false. Put that in there, do that, then if we press play, we should be looking at our metal ball here, so you can see player in range, so we can check on that as we do it. So basically click on that, checking the value, it's false, click on here again, and look at that, and look at that, goes on and off, right? So now we have our ball detecting, okay, so our player is in range. We can move and go out, and our player is no longer in range. He is in range, no longer in range, is in range. So that's working perfectly. You can see that that lines up to our walls, absolutely brilliant. And our ball is moving around, brilliant. Once we add some sound effects, etc. Okay. Now, there was one more thing I wanted to do with this, and that is basically the way the spike is going to move is we're going to rotate it, we're going to rotate the spike to be facing the way we want our ball to move, right? So we need to make sure that our spike is actually on the front. Which I believe it is, because as you can see the X here is in this direction, right? So that's good. So if we go to our event graph, right, at the start of all this, we can do look at right, and we get old position and we get new position, and that gives us a rotation. We can do another lerp if we want. Okay, so I wonder, yeah, it has. Wonder if we can just do, yeah, apparently not. Nah. Now the only one we want to actually do here is the Z. If I think we could do them all. I think we can do them all. Right, so we'll recombine that. Right, we'll just plug this in here. And we'll say take 2 seconds. Right. And we're just going to do that. And that's going to be great, I hope. Right, let's go and see, shall we? Oh, that's not good. Ah, this is relevant. This is relative location. Yeah, we don't want to move it in the relative. Right, okay. I'll tell you what, in the first instance, right, Right, delete that. We'll do self. Right, and then we'll do actor rotation. And we'll set actor rotation. Then we're going to do that. Right, we're going to put this into a layup or something in the timeline. We'll delete the sphere. Right, and then we'll delay. Okay, if I can put my fingers on the keyboard properly. Right, and let's make it 5 seconds so we get a chance to see what's going on. Right, so it should just flip straight round to the new rotation it's going to go on. Right, definitely flipped round there. Yep, so that's right. Right, it's flipped again. Okay. Now it is facing that way. It looks like it's going to go. Well, it actually went that way. That was right. Now it's going to go to the left. And where the hell did it go? Oh, it went over there. Right. Okay, so that's working. So basically what we're going to have to do is put an R timeline in here. Right, now we can have this either before or after, doesn't really matter. Right, same thing, 2 seconds, that'll do. Alpha, that'll do. Yeah, that'll do. The only thing we're going to do is rename this TL underscore rotate. That'll do it. Alright. going to lerp rotator. Okay, then that's going to be on the update. And then this is going to be on the new rotation. And we're going to have to add one here. Because we're basically going to have to get the rotation. Right, so we're going to have to say get active rotation, and we're probably going to have to put this in a variable. Because we're going to go for there. And as we move the actor rotation, then this is going to change, so it's going to get a bit wonky, right? So we're going to say orb rotation. We'll drag this over here. Then this is going to be a rotator. Then we're going to set it. It's going to go there. Then it's going to go in there. And we're going to do that. Play from the start. And then it's going to go in here. We're going to lerp. We're going to get the alpha. That's going to go up there. Then on finished, we're going to play that one. And there we go. And this is going to go away. We are going to plug it in there. And that is going to go there. And then we're going to do a self. And then we're going to say actor rotation. And get it. And that's going to plug in there. So basically what we're saying there is each time we're going to do this, we're going to get the rotation, our current rotation, right? And then we're going to rotate from our current rotation to the lookout rotation of our next position, because we're getting the rotation between old position and new position. So as you can see, I know a lot of people like this, programmers and stuff, that once you get in the groove, everything becomes very clear on what you need to do next, right? And I'm kind of in that zone right now. Right, so if we save that, then again, of course, if this doesn't work, if I've made a mistake, then it all comes to a crushing halt very quickly. Right, now that actually doesn't seem to be working. Although it did work there. You can see it moving. Yeah, it didn't need to actually rotate there. Yay, more bots. Right. Did I press stop on that? I don't think so. Right. What we need is an actual, we do need a delay. But just of a very short time before it shoots off again. In fact, a second might do it. Right, let's get these out the way. Put that there. Drag this out the way. What's going on there? Was that the delay? Oh. Okay, whatever. Right. Okay, and on that, guys, I'm going to call it for this afternoon. I'm going to have a cup of coffee and then I'm going to come on Discord. So if Jess, Mr. Spock are still there, I might be available in about 10-15 minutes. If you've enjoyed the stream, hit like and subscribe. And check out the description for Discord, Patreon, and my previous game on Steam. There's links in there. Thanks for watching, guys. Bye bye for now.